Welcome to this Algebra 2 session on power functions. So we're going to be classifying power functions represented in tables or graphically, looking at graphs of power functions, write equations of power functions given the degree and a point on the graph, determine whether functions are even, odd, or neither. So we're going to cover most of these things. You're definitely covering all of these things in your lesson, and I'm going to point out some of the more maybe difficult concepts for you to understand. One thing that I'm not going over is how to compare the graphs, so you definitely want to take a look at that. And there's also a lot of good pictures in your reference guide that show the graphs and comparing them. Power functions, they have this form: y equal to a times x to the n power plus b. N is a positive integer, a is a non-zero real number, and b is any real number. Here are some examples of power functions. A power function with a degree of 1. That means its highest exponent would be 1, is a linear equation or linear function. We've worked with those a lot. Degree 2, highest exponent of 2 is a quadratic, and that has the U shape, or it can be an upside down U, and we've worked with those a little bit. And last is the cubic, which is degree 3, and it has an S shape. And we haven't really worked too much with those, but you'll see those in the lesson. So let's talk about end behavior. This is taken from purplemath.com, this chart. The next couple slides have some things from Purple Math. Even degree polynomials with a positive leading coefficient have this U shape. And what happens is the graph starts pointing up and ends pointing up. And you can have an even degree polynomial that looks like this. It's even degree if both ends of the graph are pointing up. Or it's an even degree polynomial if both ends are pointing down. And you can see that in both of these. Now when we say a positive leading coefficient and a negative leading coefficient, that's talking about the A value. So remember I just gave you the general form, which is y equal to a times x to the n plus b. A is considered the leading coefficient. So what they're saying for these two on the left is that a is greater than 0. So when a is greater than 0, you want to take note that your graph starts and ends pointing up. Both ends are up. And that's for both of these. And then with a negative leading coefficient, that means that a is less than 0. A is a negative number. So both ends are down. Starts down, ends down for the graph. Now, so that's for even degree polynomials. So if we look at odd degree polynomials, you can see the difference. You can see that this one points down and points up. So when it starts, it's starting down and ends pointing up. So you have one end up, one end down with odd degree polynomials. And you can see that in both of these. Write that down. One end up and one end down. So what you want to take notice of, and again this is with a positive leading coefficient, you can see these two here. What you'll notice with the positive leading coefficient for an odd degree polynomial is that on the right side is the side that's up. Okay? With a negative leading coefficient, the left side is the end that's up, and the right side is down. And you can see that in both of these. So when the leading coefficient is a positive number, when the A value is a positive number, the right side is pointing up, left side down. Right side up, left side down. When it's a negative leading coefficient, right side's down, left side is up. So that's for A less than 0. And I'm going to write down here. Right side down, left side up. And then when it's an even degree an odd degree polynomial with a positive leading coefficient, it's right side up. All right, let's take a look at a problem where we have to identify its degree. So which of the following could be the graph of a polynomial whose leading term is -3 x to the 4th? So this is an even exponent. Okay, so we're looking for an even degree graph. So we said back on the chart that an even degree polynomial, both ends are pointing up or both ends are pointing down. So it could be B or it could be D. It can't be A because it has one end up, one end down. C has one end up, one end down. So neither of those can be correct. And that's again because this is an even degree polynomial because of the 4. So how do I know if it's B or it's D? Well, I look at the leading coefficient, which is -3. It's a negative number, so that means that both ends need to be pointing down when the A value is less than 0. So that means that B is a possible graph for this equation. All right, let's take a look at writing the equation of a power function that passes through a point. So if we have p of x is equal to a times x squared, and we know that p of 2 is equal to 6, we want to write the equation that has this power function that goes through the point 2, 6. So what we do is, remember this is an x value. The 2 is an x value that's being put into our equation, and when we put that 2 into our power function, we get 6 as a result. So what we're going to do, to write our power function, we need to know the a value. So we're going to substitute the 2 in for x, and we're going to substitute the 6 in for p of x. Basically, like your y value. So we're going to substitute those numbers in. So we'll have 6 equal to 2, I'm sorry, and let me move that 2 over the a first, times 2 squared. So we're substituting the 2 in for x, and we'll be squaring it. So we get 6 equal to a times 4, and we need to solve for a. So we divide both sides by 4, and we get that a is equal to 6/4, which is the same as, if we reduce it, 3 over 2. So our power function then is 3 over 2 times x squared. All right, let's look at determining the degree of a power function using a table of values. What you're going to do to figure out the degree is you're going to take the g of x row or the f of x row, basically the y value row, and you're going to subtract. You're going to look at the difference between the numbers in the table. So what I'm going to do is I'm going to start by taking, and you're going to look for the differences, and it's important that you note that it's the differences. So I'm going to be taking negative 36 minus negative 17. And again, we're doing the differences between the numbers in the table. So that's why I have a minus sign here. So it's negative 36 minus negative 17, which gives me negative 19. Then I look at the next two numbers. Negative 17 minus 2 gives me a negative 19. 2 minus 21 gives me a negative 19. 21 minus 40 gives me a negative 19. So I've had to do one row of subtractions. So when you have to do one row of subtractions, then I know the degree is linear. It's 1. The degree is 1. When you do one row of subtractions, the degree is 1. Let's write this down. And what I'm looking to do, and actually I didn't say this, what I'm looking to do is get the same number when I do the subtraction. So if I subtract and I get the same number in the first row of subtraction, then that means that the degree is 1. So one row of subtractions gives me the same difference, so the degree is 1 and it's linear. Two rows of subtractions, which I did not need to do here, gives me the same difference. Then its degree is 2, and it's quadratic, and so on. So if you had to do 3 rows of subtractions before you got the same number, the same difference, then it would be cubic. The degree would be 3. So you're looking at how many rows of subtractions do I need to do before I get the same difference. So we only had to do 1 here. We did 1 row of subtractions and we got the same number, negative 19, all the way across. So that's when it's considered linear. So we're going to write up here that it's linear, degree 1. All right, 2 more problems we're going to look at. Determining whether a function is even, odd, or neither. A function is even if you substitute negative x into the function and you get your original function back again. The function is odd if you substitute negative x into the function and you get the complete opposite function, meaning all the signs are opposites. So let's look at what that means. Your lesson talks about how you can do that graphically. I'm going to focus on how you can do it algebraically. I think your lesson covers both, actually. But I'm going to focus on the algebra part. So what we do is we're determining whether this function, f of x equal to negative 3x squared plus 4, is even, odd, or neither. So what we do is we substitute negative x into the function. So what we'll have is we take the original function and we put negative x in for the x value. So instead of x, it is negative x, and we're squaring that and adding 4 on the end. So you're substituting negative x in. So when we do that, we simplify it. Negative x squared is going to be a positive x squared plus 4. So we get negative 3x squared plus 4. So that is, if you notice, that is our original function. So when you substitute negative x into the function and you get your original function back again, that means that the function is even. So this function is an even function. And again, that's because when we substituted negative x in, to the function, we get our original function back again. Take a look at another one. This one is 2x cubed minus 4x. We want to know if it's an even, odd, or neither. So what we do, again, is substitute negative x into the function. Substituting negative x into the function, we will have 2 times negative x cubed minus 4 times negative x. We replace the x with negative x. So now you need to think of this as, when we simplify this, this is 2 times negative x cubed. So if we cube a negative 1, because really it's negative 1x cubed, negative 1 cubed is negative 1, and then x cubed. And then we have negative 4 times negative x will be a positive 4x. So 2 times negative 1 gives us negative 2x cubed plus 4x. So when we look at this function and compare it to our original function up here at the top, you can see that the 2 here was positive and now it's negative. The 4 here was negative and now it's positive. So now when we substituted the negative x in, we got the complete opposite function. So that means that it's an odd function. So when you substitute negative x in and you get the complete opposite signs for all of your terms, then it's an odd function. If you substitute negative x in and you don't get all of the signs to be opposite, then it's considered neither. So if you don't get the exact same function back again, or you don't get the exact opposite function, then it's considered neither. So it's neither even nor odd. And that ends this lesson on power functions.